Hi, welcome to the Module 3 of the Data Migration Framework course. I am Krupesh Desai, your trainer for this course and the author of the book Data Migration Framework. From here, we enter into the iteration stage of the framework, containing four components. And in this training, we will learn about the first component, the business rules. While the first three components of the data migration framework set the foundation before a single piece of code is written for data migration, we now focus on the actual operational nuances of moving the legacy data into the new target system. From here, we enter the iteration stage of the data migration project, where business rule takes the center stage, guiding the entire data transformation process and the data migration code that ensures the integrity of the migrated data in the target system. The data management body of knowledge identifies collecting business rules as a critical activity for the data integration stream, including data migration. According to the DMBOK, a business rule is a statement that defines or constrains an aspect of business processing while asserting the business structure and influencing the business behavior. Hence, I consider the business rule as a standalone component of the framework that informs stakeholders about how business rules are validated and how business knowledge is retained for future needs. A business rule is nothing but every decision made about legacy data to perform data migration, starting with the data migration scope in the foundational stage to defining mappings between source and target data structures during the iteration stage. In the data migration context, an iteration refers to one data migration test run cycle that discovers gaps and issues as if you are executing an actual data migration today. An iteration begins with preparing the source system for data extraction, extracting the legacy data, transforming it to fit the target data structures, and loading the transformed legacy data into the new system. An iteration is logically successful if users can execute business operations and the new system with the legacy data migrated in that particular iteration. If you can scope out each iteration and define success criteria for an iteration before executing it, you can measure the progress of data migration project after each iteration. During an iteration, you could find issues and limitation at any stage of the journey with repercussions on one or more stages of the iteration. For example, after migrating employee master data in new payroll system, you find UI UX issues in employee registration screens when updating phone numbers of existing employees migrated from the legacy system. The root cause is the employee mandatory team allocation ID, which is missing in the backend. In this case, if the number of team is small, which is let's say less than 50 or 100, you could manually load team master data in the target system to generate the team IDs and map them with the legacy team ID in the next iteration. At the same time, the vendor must ensure that the attribute team's ID is mandatory in the data upload template for employees. Being mandatory at the load stage, legacy employee data without team ID cannot make it to the UI UX or the UAT testing and parked for the further investigation for the next iteration. So here the idea is for the first iteration, start small with one or two logical master data set, such as patient, customer, store location, and use temporary placeholders as business rules. Subsequently, as the scope widens, the frequency of approving, adding, and modifying business rules intensifies, with discoveries in each iteration until there is no issue or gap in the data migration. It is worth noting that your ETL solution or specialized data migration tool must be scalable to handle iterative enhancements and changes to the data migration flow and keeping a log of all the data rejections throughout the iterations. Data migration is about meaningfully moving data from one structure to another, preserving its integrity, context, and usability. Therefore, it requires well analyzed and validated mappings of data structures with the legacy data structures. In the last chapter, we learned that the target system data structures could be tables and columns in an actual SQL database, or it could be a bunch of Excel or CSV files, or it could be RESTful APIs with endpoints to push legacy data into the new system. Whatever the means on the target side, each attribute or a column of the target table or a API must be mapped with the legacy data structure. Mapping decisions made for data migration directly impacts business continuity after the retirement of the legacy system. Therefore, I see each data mapping decision as a business decision that must be reviewed, approved, and documented as a data migration business rule. Trivial choices such as using any default values as unknown or none, or even leaving something null for the target field, are also part of mapping and thus a business rule. The data management body of knowledge defines mapping as a synonym for transformation that addresses both the process of developing the lookup metrics from the source to target structures and the result of that process. A mapping defines the source to be extracted, the rules for identifying data for extraction, targets to be loaded, rules for identifying targets rows for updates, and any transformation rules or calculations to be applied. In some cases, especially the master data, this mapping could be simple with one-to-one match between the source and the target system. For example, customer first name in the source system and customer first name in the target system. However, mapping could get complex when the target data structure demands that the value must be derived or transformed from one or multiple attributes in one or multiple tables of the source system. On the other hand, reference data such as gender codes or product type would differ between legacy and target system, requiring a lookup structure to derive the correct target value from the source value. That is, the word M in the source is male in the target system. You can also come across some mandatory fields or column in the target system that are unavailable in the years old legacy system, leading to a hard-coded default value for migrated data. In the next slide, I try to represent a very highly simplified example of capturing mapping between source and target data structure for few fields when migrating patient data. System matter experts should review and validate such mapping before database developers can implement them in the ETL code. Here's the first example. We have this one-to-one mapping with a fair amount of data cleansing to be done. Whereas the another example I'm highlighting is a derived value. You are using multiple attributes of the source to derive one value for the target attribute. And here is the logic for that, how to transform those fields into one value. Comes the second example that I want to highlight, the mapping of referential data. So here, to map the smoking status of a patient, you can do that in the transformation code because it's a simple mapping. Whereas mapping the country code of the patient requires a lookup map to map the country codes in the legacy system with the country codes in the target system. With the simple mapping example in the previous slide, we can see that a mapping for a target structure is a bunch of business rules that control data transformation from source to target system. Let's look at the significance of business rules in more depth. A business could lead these business rules retrospectively after the retirement of legacy system for various analytical or compliance need that demands legacy data. Thus, it must be captured, curated, and approved by system matter experts or stakeholders and made available in a human readable form. Poorly executed data migration, where the mapping between source and target structures was considered a purely technical job, would bury all such business rules in the data transformation code without any scrutiny for transformation logic or default values for the mandatory fields, causing significant risk in meeting analytical needs and disturbing downstream data feeds to integrated systems. The rules that map the target data structure with the legacy data to transform or cleanse the data during migration must be explicitly validated and documented as business knowledge. When such significant business knowledge is buried in the data transformation code and in the developer's head who no longer works here, legacy and current data aggregation would depend on a massive reverse engineering exercise, causing doubts about the integrity of the combined data set. Therefore, the value of your work in documenting these business rules cannot be overstated. Documenting business rules for such a significant transition would add value as metadata generated from the data migration, and it can serve as a reliable reference for future analytical or regulatory needs that demand data aggregation from legacy and current systems. Please refrain from attempting to list all business rules in the plan, as they will emerge and develop as the data migration project progresses. Instead, focus on including information about how business rules are validated, who, that is the SMEs, are responsible for the validation, and provide a reference to the location where business rules are documented. Depending on the culture, budget, and preferences, one can capture business rules in a simple Excel file saved in a SharePoint, or go for a sophisticated business rule engine that allows non-technical users to manage business rules. As a data migration lead in my first project, I used to build mapping files in Excel, which I can use in my brief dedicated time with the system matter experts to run through them over my proposed mapping for their validation. It was always a productive exercise with 2 or 3 rounds per Excel file that ensure comprehensive business rule gathering, well-structured ETL code, and data pipelines that execute those business rules on the legacy data. The data migration process and the underlying ETL code gain trust due to this thorough SME validation of business rules. In my most successful data migration, I analyze every attribute of the data upload template provided by the vendor. For each target attribute, I captured information about how data is populated during the data migration. In hindsight, having business rules validated by the system matter experts for each target attribute did not eliminate all issues and surprises during the test run. However, it established a process to raise and prioritize new issues for timely resolution or business rule formation, eventually leading to successful data migration on the go live night. We will see how this simple and fine-grained approach to business rule validation assisted me in measuring data migration progress in the last iterative component called the iteration goals. For now, the key point to note here is to analyze every target attribute and generate one Excel file or a spreadsheet with business rules for each target data set. These files with business rules should be a project deliverable and part of the data migration project files. Your data migration plan should point to the locations and the names of these files where the business rules are captured. You will thank me later when your decision support and other data analytic tribe utilize this comprehensive and validated documentation multiple times after the go live. So, leverage the fourth component of the data migration framework to create a process for curating and capturing critical business knowledge generated due to the decommissioning of the legacy system and decision made on legacy data during the data migration. Overall, this component should answer the following questions for your project. Thank you. Please continue on the next video on the second iterative component, data quality.